So now that we know the difference of a primary and a secondary air pollutant, we're going to go into them a little more specifically. So we'll start out with particulate matter, which is a primary air pollutant. And if you see here, suspended particulate matter means that it's suspended in the air. And so we note it with a PM and a subscript of 10. That's the diameter. And so particulate PM10 is a diameter of 10 microliters or less, and a micrometer is 1,000 times smaller than a millimeter, and there are 1,000 millimeters in a meter. So a micrometer is actually 1/1,000,000th, or 10 to the negative 6 meters for future conversions. And so particulate matter includes smoke, dust, soot, lead that can be up in the air. Asbestos is also considered a particulate matter. So really it's any solid piece of material that is up in the atmosphere. And this can come from burning wood, fossil fuels, and if you look at diesel vehicles, they actually end up giving more particulate matter than gas-powered vehicles. So, for example, if you look at a truck that's running on diesel, you'll see a lot of black smoke coming out. And so, diesel actually tends to last a little bit longer. You get more miles per gallon, end up emitting less carbon dioxide, but you end up emitting a lot more particulate matter. Particulate matter can be very, very dangerous. And so the smaller it is, the more dangerous it becomes to human health. And particulate matter causes haze, which is the scientific way of saying that we have reduced visibility. It can cause lung irritation and damage. So if you have any solid material going into your lungs, hopefully, obviously, that will hurt. And so some of them are mutagens, causing mutations, teratogens, and carcinogens. And like I said before, the smaller the particulate matter, the more hazardous they become. And so particulate matter of 2.5 are even greater health concern because they can get deeper into your lungs. So our next pollutant we'll talk about are NOx, or nitrogen oxide. So this includes nitrogen oxide and nitrogen dioxide. And they easily switch from one to another. Nitrogen oxide becomes nitrogen dioxide and vice versa. And so pretty much any time anything's combusted, it will form nitrogen oxides. So that includes natural sources like forest fires. Lightning actually causes nitrogen oxides, and even microbial action in the soil will give us nitrogen oxides. But of course, the combustion of fossil fuels will obviously give us nitrogen oxides as well. And so motor vehicles, we burn gasoline and diesel. And then a stationary fossil fuel combustion. So coal is a source of nitrogen oxides along with natural gas as well. And so nitrogen oxides are actually really important because they play a role in forming ozone, which is a secondary pollutant, and other components of smog, which we'll talk about in depth in just a little bit. So nitrogen oxides also combine with water to give us nitric acid, and that gives us acid deposition. Again, we will be talking about that in depth. And nitrogen oxides, these reactions of nitrogen oxides result in lung irritation, damage, can suppress plant growth, so stress the plants and not allow them to grow as they would. And it's possible that they may actually be a carcinogen. Sulfur dioxide is actually a pretty corrosive gas. If you look here in the picture, this is sulfur dioxide damage to leaves. We call this foliar damage, and it is primarily coming from combustions of fossil fuels. Again, fossil fuels contain sulfur, and especially depending on your quality of coal, you can have more or less sulfur, but all of it has it. And when you combine sulfur with the oxygen to burn it, you end up with sulfur dioxide. So sulfur plus oxygen gives us sulfur dioxide. Um, and it's released in very large quantities in volcanic eruptions. But mostly where it's coming from is this anthropogenic burning of fossil fuels. And it can be an irritant for humans. It can adversely affect plant tissue, like I said. And not only that, it can be a reaction in the atmosphere with water vapor to give us sulfuric acid, which again gives us acid deposition, which we will talk about at length in a little bit.